Hello, my name is Neha Yadav, and I'll be walking you through my visual analysis of my infographic on ocean acidification. Before we get started, I'll be displaying two different types of infographics. Since I couldn't find a color model that fit my vision, I made two versions of my infographic where one utilizes the New Year's Eve model and another utilizes the color content model as shown before you. To start off, there are 5 forms of visual potential that I used in order to create my infographic: appearance, relationships, time, numbers, and location. Visual potential is essentially when you're transforming a concept into a visual representation which would contain different visual attributes so that the illustration is perceived easily by a viewer. Without visual potential in an infographic, viewers find it hard to understand information to the fullest extent. The visual potential of appearance allows the user to understand what a display is describing without requiring the viewer to rely on supplementary text of the guide. Instead, a viewer can recognize what a display is explaining at a glance and gain more information about a topic that they may have heard about but have not delved into completely. In simpler terms, appearance relates specifically to how an icon or display looks. Visual potential of appearance can be implemented through a variety of actions, such as adding icons, photographs, realistic drawings, and silhouettes. Since my visual language model utilizes appearance for general understanding of topics, there are many occurrences of visual potential of appearance within my display. For example, I utilize a realistic icon with a few details of a clock tower to represent the fact that a full recovery of ocean acidification can take a millennia. My understanding is that when a person looks at the clock tower, they instantly think of time and assume that a time was associated with ocean acidification. The same could be said for my display of which organisms are affected the most by ocean acidification. When a person would view the display, they would recognize that certain icons are related to marine life. Finally, when trying to illustrate how much carbon dioxide is consumed by the ocean, I chose to represent carbon dioxide as air bubbles in a beaker to display the connection to chemistry. Throughout my infographic, I continue to stray away from detailed images and instead make the icons be more realistic in nature to match what is shown in my visual language model, which I'll go more in depth in later. Some of my displays are clearly associated with appearance. However, there are some displays that utilize appearance and aren't defined by their appearance-like qualities. For example, my numbers display utilizes a lighthouse icon with waves to indicate to the user that the graph is discussing our oceans. The visual potential of relationships conveys links within concepts or objects which can be displayed as steps or states, Venn diagrams, process flow diagrams, or source-destination connections. My display utilizes the aspect of a process flow diagram to project the chemical process involved when carbon dioxide meets our ocean's waters. I actually found it a bit difficult to illustrate this chemical process because I didn't want my viewers to rely on past chemistry knowledge to understand the content, and I also wanted to present the correct information about the process. Also, I found that at a first glance, most people weren't able to make the connection that the chemical process was linked to shellfish specifically. So I placed a few icons to get the message across more easily. The steps along with the blue connected line should indicate to the user to start at the top and move their eyes downward. Also, the title at the top of the display indicates the start of the display. The visual potential of time answers the question of when events happen relative to each other by easily equating spatial positions with the time for the viewer to better understand. One way spacing can be inherent goes back to the notion that for timelines, people read from left to right to interpret time passing by. Time can be represented through timelines illustrating time patterns, and time series. Time as a sequence where events happen before or after other events. Time as magnitude where events happen for longer or shorter periods of time, and there are different sizes of gaps between when events occur. And finally, time as patterns where events happen daily, seasonally, or annually. I utilize the timeline to describe different events that have shown human involvement addressing ocean acidification, starting from the Industrial Revolution. Since most people start timelines from the left-hand side, I went against my visual language model and made the timeline start on the left and then use a thick blue curved line to guide the viewer's attention within the display. The visual potential of numbers utilizes different charts and graphs to display comparisons between proportional values as seen in my line chart. Visual potential of numbers can show a distribution of correlation of values, a trend or a pattern over time, a comparison between categories, or a comparison of values across geographic locations. I chose to utilize a line chart because most graphs that illustrate information associated with ocean acidification are represented as line charts. Also, my visual language model utilized a line chart for their numbers display, so the two reasons played hand in hand. Even though line charts are common in many infographics, I felt like my display of the line chart was unique in the sense that I utilized the icons around the graph to set the stage for information. I also remember to keep my icons abstract but realistic in nature, and even though there is a bit of empty space, the carbon dioxide bubbles helped fill the gaps. I also try to fill certain areas of the lighthouse icon to match the visual language model, but I found it a bit difficult to not overwhelm the viewer with color. Finally, the visual potential of location should communicate the positions of places or events relative to each other in the world. Location displays can be at any scale and could be relative versus absolute, as well as being imaginary. I decided to include a world map in my infographic to indicate how much carbon dioxide is being emitted around the world from a diverse set of countries. I believe that a world map could help the viewer attain this knowledge in a quick manner. In order to help guide my final infographic representation, I retained a set of models that I referred to for influence and inspiration while utilizing them in order to make design decisions. I utilized the same example model for all my models. A visual language model focuses on the look and feel of display while adding a level of realism and detail compared to abstraction and simplification by considering shape quality, line treatment, texture, and fills. My display utilizes many lines that are relatively thin or are prominently medium. My visual language model utilizes icons that are realistic but abstract, so they don't involve much detail. The model uses thin outlines on icons and fills in major icons. The model uses minimal shading and fills objects with patterns occasionally as well as with major icons, and utilizes minimalistic transparency. The model doesn't include shadows or gradients, and moreover, there are no photographs utilized in the model. I emulate my visual language model by using realistic but abstract icons and no photographs. I fill in major icons like the world map or the clock tower, and many of the lines that I use are thin, and the only thick lines are present in the title section and in the timeline. I utilize thin outlines for the numbers display, relationship display, and introduction display, while filling in the world map and clock tower. I don't utilize much shading within my icons, which is something I could improve upon in the future. The same could be said for the minimalistic transparency. I did not utilize any shadows or gradients like my model. A color model defines which colors you can utilize within your infographic, as well as defining how colors being used for certain icons or headings. I chose to focus on the colors for the New Year's Eve model so I could better understand how color is used within the model versus making color the content as seen in the color wheel model. I figured out how to utilize 3 colors to illustrate my ideas to the fullest. Personally, I did not think that this model added to the vision I had for the infographic, so I chose a different color palette and experimented utilizing those colors as well. Apart from the white and black colors, the model has a split complementary color harmony palette, and the tone of colors is meant to instill the fun, energetic feelings from the topic, as well as having the calm blue color of the ocean. There wasn't much highlighting within the model, so I only highlighted the different areas of carbon dioxide emission. I preferred the color contrast from the light white landscape and the blue ocean. My model uses color encoding for titles and subheadings, mainly, as well as important facts within annotations. Within the relationship display, specifically color is used to encode different atoms for easier understanding. The colors aren't specifically used to trigger associations, but you could state that the blue in the color palette relates to ocean waters. A typography model demonstrates how the text supports and complements the visual elements. When analyzing my text, I found that there are 2 types of fonts, MB Vintage Bold and Myriad Variable Concept Light. I did not make any changes to the font, as my typography model had only used those exact 2 fonts as described. For the MB Vintage font, all the text in the model is capitalized or uppercase to represent important words. However, because my highlighted words are longer in nature compared to the model, making them all capitalized made the infographic spacing and alignment look off. Some text using the Myriad Variable concept is bolded for subheaders, but the font size remains the same. The font sizes for the larger fonts remain consistent, and the font sizes for the smaller fonts get a bit smaller for some displays because of the overall layout and appearance of the displays. But in general, I tried to make sure that the fonts were as large as possible in their allocated space and fit with the model's appearance. I do utilize precision labels and identity labels. Precision labels identify precise numerical values as shown in my location display, whereas identity labels clarify what different graphics are represented as seen in my timeline icons. I use proximity whenever I label a diagram in my infographic as seen in my visuals. I also use leader lines and colors by highlighting the lines in order to emphasize the important parts I want users to notice. Text is utilized to annotate in my display. And finally, for my layout model, it relates specifically to the size and orientation of the pages as well as the relative positioning of sections in comparison to itself. Holistically, you could say that there are 4 main sections and 6 smaller sections within those sections. Some displays are grouped together to form a larger section. For example, my numbers, appearance, and relationship displays are all grouped together in one big section. If some sections are separated, it is commonly used from gold-yellow lines. However, some displays aren't separated with lines. For example, my timeline isn't separated from the main section above it or by the appearance displays below it. I believe my layout emulated my model very well because it uses similar displays for certain areas. There are some cases, though, when I incorporate displays that don't directly match my layout model. For example, the top section below the title section includes 3 small displays that don't match my model's layout. But I feel like having that diversity in my infographic makes it more unique. Moving on to encoding. Encoding refers to the transforming information or data attributes such as magnitude or category into visual attributes such as size, position, or color. Encoding is a central part to many data visualizations, especially to number and relationship displays. Starting top down on my infographic, in my location display, I use encoding to represent that distance to the right translates to the east, to distance to the east, as well as distance up translates to distance to the north, and vice versa. I utilize color encoding to help the viewer discern the land and water areas, as well as utilize yellow to indicate carbon emission. I encode the different location data based on size to represent the bigger the triangle, the more carbon dioxide that country emitted. For my relationship display, I color encode the blue line to discern the chemical process relating to the line color of a shellfish icon. I also utilize line treatment in the display for making the chemical process line to be the thickest compared to the addition symbol or the bond lines for the chemicals. When looking at my numbers display, I utilize the height, length, and amount of different points to encode our ocean's transition to acidity. Finally, for my time display, I utilize the left to right encoding to follow where viewer's eyes most likely travels. I utilize line treatment for the process flow timeline to indicate that the viewer's eye should travel down the line. Since my model didn't have much encoding within its displays, I could have spent more time encoding different parts of the display. However, previously, I didn't want the viewer to assume that there were certain patterns between different icons or displays when there wasn't one, which is why I chose to keep the encoding simple. Visual hierarchy refers to a variation in visual prominence of elements within a display. Generally, more visually prominent elements will attract a viewer's attention, and you can take advantage from this attention to help guide your viewer. Without this guidance, the viewer has to decide where to look at, which can be cumbersome at times. Visual hierarchy also conveys importance as well as bring dramatic differences to the table, making your infographic become more interesting and dynamic. Since my infographic is tall and vertical, the title section is significantly larger than the other sections. People are naturally inclined to read from top to bottom and then left to right. By having the title page be the largest section, people can understand what the infographic discusses early on. The next prominent display would be the world map because of its size and color contrast. I wanted the viewer to understand where in the world ocean acidification is present. The next display in the hierarchy would be my timeline because of the space and stroke weight of the process flow line. The icons itself don't grab that much attention since they're the same size as other icons, but the process flow line does. Finally, the icons at the very bottom are the largest, which draws the viewer's attention to the text. Unity describes infographics where different visual attributes like color, shape, size, and texture are repeated across a presentation and creates a sense of unity. Without some repetition within an infographic can appear random and thoughtless with groupings of unrelated items. Variety, on the other hand, is when you should include diversity and dynamic visuals through color, shape, size, and texture while still maintaining a balanced display. I would say there's a balance between warm and cool colors in each display, even though it may seem that the warm colors are more prominent against a dark background. I was intentionally trying to keep the colors balanced, but that doesn't seem to be the case in the end, so that could be one place where I could improve upon. However, it does go without saying that the balance between the colors doesn't take away from the variety in the visuals because of the organization and size of the elements to make the display more dynamic. There is also unity within the text by keeping the text hierarchy similar to my models. Alignment pertains to arranging text or graphics so that they line up in a similar fashion. Sometimes alignment is obvious, and sometimes it can be so subtle that when done well, it significantly contributes to the infographic's refinement and therefore its credibility. Within my model, the appearance display of different icons are aligned on the same centerline axis, either in comparison to the text or icons. In this display, it is explicitly clear that the icons are aligned. However, in my time display, certain icons plus text are aligned in a subtle manner that doesn't make the infographic look random. Also, depending on the space available, texts are left, center, or right aligned to make the most out of the space. For example, for the location labels, the text was right or left aligned to match the position of the labels. Furthermore, in the numbers display, the line chart points as well as the helpful leader lines are aligned to meet the text labels within the axis and acidity bar. And that concludes my analysis on my infographic. Here are my final products as well as my models, and thank you for listening.